Hello and welcome to HWRD. In this video we're going to have a look at HP 53310A, a Modulation Domain Analyzer. We got this instrument advertised as is, but it was actually passing the post and all cal tests, and it was actually working. It was doing frequency deviation measurements in the lab just fine until it started giving out this characteristic whiff of cat's piece from old electrolytics. So I started disassembling on it. I'm not going into much details as to what does it do. In this video I'll dedicate probably a separate video to illustrate potential of this instrument in embedded development and precision measurements of clock deviations, but let's see what it looks like. So the power supply still gives this cat's piece, or as people politely say, fried salmon smell. We're gonna put the unit on the floor and perhaps start disassembling. Alright, so here is our unit. You see the CRT section on the left with CRT controller underneath and power supply atop of the stack of the PCBs that do the actual work on the unit. We start the disassembly by pulling these two stakes on the ends of the power supply. Then it's a matter of disconnecting our supply cables to CRT unit and to the PCBs. And the unit should slide right out, I suppose. Yeah, it actually does. Right, with that out of the way, we can see our main PCB. Top of the stack with that, this is the CPU and something like another Motorola CPU, empty space for ROMs. I guess some extensions possible. This looks like NVRAM chip storing the calibration settings. And underneath you can see a ref section with coax going in. So a nice, not too dirty unit actually, other than this power supply. It looks nice, but it smells. So I think our troubles are focused in there. Alright, let's open up this guy. It is held by a bunch of screws with spring shims made with some concern for vibration apparently. Now I think it slides right off. Yeah, and look at how many caps are there. It's really enormous amount, starting from some big electrolytics right here to, well, bunch of smaller ones. None of them seem have their heads popped, but we know they're bad because they smell. They smell bad. Oh yeah. This is looking a lot like Rifa cap, but it's not the orange yellow one, so I think we're safe with that one. The concern is this guy on control PCB, and replacing it might require tweaking these sealed pots on the side, but I hope not. Okay, I have first few pulled, and just look at this. Let the camera focus, but I hope you will be able to see the glint of the leakage. Yeah, I think you can see that. See that? That's the stuff going down on the bottom, and it's impossible to see on the outside. So Yeah, all these guys here and there were leaking underneath. So that's that whole bank of smaller caps, and the caps over there also stink quite a bit. So everything has to be pulled. Yeah, so I got rid of all of the caps except for these two guys. This small 47 microfarad here and this one on the control board. As you can see, it's a bit of desoldering to do to get the control board out, but that's not my biggest concern. The actual concern is I would need to adjust this pulse again. So, right, it leaked quite a bit here, and over here it was quite a pain to remove the caps, and some terminals still stick out, but otherwise I got rid of all, and yeah, they leak a lot, and not in a manner that's readily visible from outside, so you can only smell it. This has sink gave me trouble desoldering the terminals, but now it's done. So I got the control board pulled and this capacitor removed, 47 micro, and that's what it looks like. It wasn't leaking, but it was smelly. And there is another one over here, which was also pulled. It was hard to see, but now we are all electrolyte free. I washed the board with isopropanol to the best I could, and it smells better now. So now the matter of assembly, putting the caps back and putting this control board back onto the PCB